Hi everybody, myself Swapnil Joshi. We are Team Intelligentsia. Our topic is predictive model for nation development with infrastructure data. As per theory, there are several known factors that directly contribute to the GDP of a country. However, in real world, there are many additional factors that may not be contribute to the GDP growth but have considerable influence. The objective of this project is to identify the independent factors that influence the growth of GDP and perform GDP prediction based on the various in these factors. Country's growth can be predicted based on the GDP. So we decided to measure country's growth based on GDP per capita factor. GDP per capita is normalized GDP based on population of the country. We also collected imports and exports related data of goods and services to analyze the impact of exports and import on GDP per capita. For deciding for deciding influencing factors, we use methodologies such as Pearson, Kendall's, and Spearman's rank correlation coefficient. After deciding factors based on these methodologies, we created a regression model using different algorithms such as linear regression, multiple linear regression, and random forest algorithm, and compare this model with each other by calculating RMSE's values for the test data. I worked on data processing, data cleaning, and finding out influencing factors based on correlation coefficient. For this project, we collected data from three different data sources. We developed Java standalone application for data collection task. After collecting data, we cleaned such data for which for which values are not present. Then we used scale normalization to scale data on 0 to 100 scale. To find correlation coefficient, we use three different methodologies. Pearson correlation measures the linear relation between two variables. Spearman coefficient is a non-parametric measure that is helpful in case of abnormal data distribution. It is used to detect the nonlinear relationship in the data. Kendall's correlation is an equivalent measure to Spearman, which also considering the statistical capabilities. After applying these algorithms for factors such as electric power consumption, broadband subscription, and internet users, we got correlation coefficient more than zero point 0.6. Based on these results, we finalize these three factors as major influencing factors for GDP per capita. Next part will be explained by Apurva. Thank you.
Hello, myself Apurva Dikshit. I will be presenting details about the system design for our project. As shown in the diagram, the system is divided into four modules consisting of interactive user interface, data cleaning and pre-processing unit, coefficient computation unit, and predictive model builder in R. I will explain the working of the system based on these modules. In the data processing and pre-processing module, we pre-process the data by combining data from various datasets to obtain a final dataset with all the required parameters. The cleaning of data involves eliminating zero values from the dataset. The tuning process is where we normalized our data. When a user accesses the web application and selects certain parameters like years, dependent factors, and independent factors, the control is passed on to the coefficient computation engine. The coefficient computation engine is responsible for finding the correlation between all the selected factors. Here we select the factors which have high correlation coefficient. Once the factors are selected, the control is passed on to the predictive model builder in R. According to the option selected by user, either multiple linear regression or random forest algorithm model is implemented. The regression analysis is the statistical process for estimating the relationships between different factors. The algorithms like random forest were considered for building the regression model. The random forest algorithm is used to build regression trees. These trees are used for nonlinear multiple regression. We built this model to analyze the RMSE values for the train and the test data for certain factors. As shown in the tables, we got to the conclusion that when all the factors are considered for analysis, RMSE values for train and test data are pretty close. Random forests tend to give better results than using a single decision tree. This is because the predictions from different trees have very little correlation with each other. The next regression model will be explained by Viresh.
Hi, I'm Viresh. In addition to what Apurva discussed in previous section, I'll be explaining about the regression models that we have implemented in this project. Regression is basically the prediction methodology when it comes to statistical computing. It basically models the past relationship between variables to their uh, future behavior. One of the simple example would be a company trying to understand the relationship between advertising expenditure and the sales. There are two type of linear regression methods: simple linear regression and multiple linear regression. We have used both of them in our project. Now we'll discuss about the simple linear regression first. A simple linear regression uses one independent variable and one dependent variable. It tries to best fit a straight line through the points observed for the two variables. The simplest example would be a Celsius and Fahrenheit scale where one increases with the increase in other. This is a snapshot of our application where we have selected one dependent variable as GDP per capita and one independent variable as electric consumption. On the right hand side, you can see the calculated intercept, coefficient, and RMSE values for the same. It is clearly visible that the points were not well fitted with the simple linear regression lines, which means we might have to consider more factors that leads to the multiple linear regression, which we'll discuss in the next part. Multiple linear regression attempts to model the relationship between two or more explanatory variables and a response variable. Rather than modeling the mean response as a straight line, as in simple regression model, it is modeled as a function of several predictors. The LM function for multiple linear regression and simple regression is pretty same. Only the change is the number of predictors that increases with the multiple linear regression. For selecting the best factors, we use two popular methodologies that are called as forward selection and backward elimination. In forward selection, at each step, each variable is not already in the model is added to the model. The most significant of these variables is added to the model as long as the p-value is below a set level. Whereas in the backward elimination, the model starts with all the predictors and the variables that is less significant, that is the one with the highest p-value, is removed and the model is refitted. This is a snapshot of our multiple regression result from the application. We can clearly see here that the points are now well fitted along the regression line as compared to how it was when we had the simple linear regression line. For this example, we had selected GDP per capita as our response variable and all the other selected variables as the predictors. Based on the RMSE values shown on the train data and test data, we can observe that the RMSE is close to being precise with this model implementation with lower p-values. Also, we can see r squared value which is in the range of 0.65 to 0.75, which depicts the good quality of the model. All these results motivated us to incline towards the multiple linear regression model as the best option for the predictive modeling of the data we have considered for this project.
So we conclude that with correct selection of factors, it is possible to identify the factors from the infrastructure data that influence the growth of GDP. These factors may not be directly contributing to the GDP in theory. However, in the real world, the changes to these factors impact the overall GDP and the growth of a country. Thank you.
So we are using the Shiny R for analyzing the data in interactive manner using the web application. So to analyze the Pearson correlation, this is the web app that we have developed. So here from the years list, you have to select a year. I am selecting a scale normalized data. That is the year between 1980 to 2012. Then I am selecting a dependent variable, which is a GDP per capita. Now I am selecting an independent variable, which is, let's say, electric consumption. Now you can see this application is creating or showing the Pearson coefficient, Spearman coefficient as well as Kendall coefficient dynamically based on my selection. This is the web page that we have created to predict or to build a predictive model dynamically using the selected factors. So here I am selecting a scale data, then selecting a type of a model that I want to evaluate. So let's select a multiple regression. Then I am selecting a dependent variable, which is the GDP per capita. And now I am selecting the all the independence factors. So I want to build a model for all these independent factors. So as you can see, as I'm selecting these factors, these data is changing dynamically. So for this selection, I am getting RMSE of 13 for the test data and RMSE of 12 for trend data, which is quite good. Even the R squared value for this model is 0.71, which is a decent value. So now I am selecting another regression model, which is a random forest. So the data gets changed for this model dynamically. Now it takes little bit time because, all right, so here I am getting the RMSE value for test data like 8.5, and the RMSE value for train data is 3.8. So in our project we conclude that the multiple linear regression model is best suitable to predict a nation development based on the infrastructure data. Thank you.